Hello friends, I welcome you in lecture number 12 on complex integration. In this lecture we are going to discuss one more problem on evaluation of complex integrals. So this question was asked in GTU Winter 2019 exam. For this question we must be familiar with two important results for complex integration. First result is Cosi-Ursa theorem, which we have already discussed in earlier lectures of complex integral. So we just recall what is Cosi-Ursa theorem. So Cosi-Ursa theorem says that if complex function f of z is analytic at all points inside, that is interior, and on a simple closed contour C, which we considered in counterclockwise direction, taken in counterclockwise direction, then integral of this complex function over this simple closed contour is always 0. So this is very important result. If function is analytic at all points inside some simple closed contour C and also on this simple closed contour C. Inside means function must be analytic at all points inside the given simple closed contour, and on means it must be analytic on the boundary of the simple closed contour. So if function is analytic at all points inside the simple closed contour as well as on the boundary of simple closed contour, then integral of that complex function over that simple closed contour is always 0. Another result which we require for this problem is Cosi integral formula. So for Cosi integral formula also we require that function f of z is analytic at all points inside and on some simple closed contour. Suppose this is simple closed contour, and suppose we have complex function f of z which is analytic at all points inside and on this simple closed contour C, and suppose z0 is some point inside this simple closed contour C. So z0 is interior to this simple closed contour C, and function f of z satisfies this condition. F of z is analytic at all points inside and on this simple closed contour C, which is considered in positive direction or counterclockwise direction. Then suppose we are interested in the integral of f of z divided by z minus z0 to the power n plus 1 over this simple closed contour, then Cosi integral formula says that value of this type of integral is 2 pi I divided by n factorial times nth derivative of this function f of z at point z0, where z0 is a point inside this simple closed contour C, and this is valid for n equal to 0, 1, 2, 3 and so on. So it is valid for n equal to 0 and for every natural number n. So here if we have this type of integral, then we can apply Cosi integral formula. So here again we repeat that if we have this type of function f of z divided by z minus z0 to something n plus 1 say, where this f of z is analytic at all points inside and on this simple closed contour, and this z0 lies inside this simple closed contour, then if we have this type of integral, then value of this integral is obtained by 2 pi I divided by n factorial times nth derivative of this function f of z at point z0, which is inside the simple closed contour. So for this question we require knowledge of these two theorems, Cosi-Ursa theorem and Cosi integral formula. So now we check first part. In first part our function is z plus 3 divided by z minus 1. So this is a rational function and we know that this function is analytic everywhere except one point, which is z equal to 1, because this function becomes infinite at z equal to 1. So this function is analytic everywhere except z equal to 1. Now in first part we have to integrate this function over the circle mod z equal to 2. Suppose we consider rough sketch. Suppose this is simple closed contour which is circle with center 0 and radius 2. Then we have somewhere here say 1. So if we consider integral along this circle mod z equal to 2, then we can observe that this z equal to 1 lies inside this simple closed contour. So here we can use this result, f of z divided by z minus z0 to the power n plus 1 dz, and here we can see that z0 is 1, f of z is z plus 3, and here we have single power of z minus 1, that means we consider n equal to 0. So if we take n equal to 0, we have f of z divided by z minus z0, and this is going to be 2 pi I times value of function f of z at point z0. If we use this result for n equal to 0, we have f of z divided by z minus z0 to the power 0 plus 1, that is z minus z0. This is equal to 2 pi I divided by 0 factorial, and 0 derivative means function itself at point z0. So we will use this formula for first integral in part 1. So this integral looks like this one. So we will use Cosi integral formula with f of z equal to z plus 3. So first we complete this part, first part of part 1. So in that part we have this simple closed contour is mod z equal to 2. We have to integrate given contour is, we can write that given contour is circle with center 0 and radius 2. So we just consider rough sketch. Let me try to sketch it properly so that it looks like circle. Okay, this is just for understanding. It is not necessary to sketch the figure, but if you sketch the figure you will have clear idea about the situation. So here we have 1, this is contour mod z equal to 2, this is real axis, this is imaginary axis. Now function z plus 3 will be considered as f of z. So we consider f of z equal to z plus 3. So f of z is a polynomial function, so it is analytic everywhere. So therefore it is analytic at all points inside and on this simple closed contour. So clearly f of z is analytic at all points inside and on simple closed contour C. And we can see that this point 1 where given function is z plus 3 divided by z minus 1, and we want to integrate this along this contour mod z equal to 2. So this function is not analytic at z equal to 1, and 1 is inside this simple closed contour C, or we can write in this way also, 1 lies inside circle mod z equal to 2. So therefore now we can apply Cosi integral formula. So therefore by Cosi integral formula, integral of z plus 3 divided by z minus 1 over closed contour C will be equal to 2 pi I times value of f of z at z equal to 1. F of z is nothing but z plus 3. Okay, here we can write one more step. We have f of z divided by z minus 1. F of z is z plus 3. So here we find out value of z plus 3 at z equal to 1. So it is nothing but 2 pi I times 4. So value of given complex integral is 8 pi I. So therefore integral of the function z plus 3 divided by z minus 1 over circle mod z equal to 2 is 8 pi I. So this completes part A of first part. So we obtain that value of this complex integral along mod z equal to 2 is 8 pi I. Now we consider part B. In part B, our simple closed contour is circle with center 0 and radius 1 by 2. So now we try to find out integral in part B. So here given contour is mod z equal to 2. Given contour is mod z equal to not 2, it is 1/2, 1 by 2. And function is z plus 3 divided by z minus 1. So if we consider this circle with radius 1 by 2 and center 0, then we can see that suppose this distance is 1 by 2, so we have 0 here. So suppose this is circle with center 0 and radius 1 by 2, then this function is not analytic at only one point, which is z equal to 1, but z equal to 1 is outside this circle. So it is clear that z plus 3 over z minus 1 is analytic at all points inside and on this circle, at all points inside and on this circle, which is mod z equal to 1 by 2. So here we can apply the Cosi-Ursa theorem. So by Cosi-Ursa theorem, integral of this function along mod z equal to 1/2 must be 0, because this function is analytic at all points inside and on this circle mod z equal to 1 by 2. So we can understand we are having same function, but here integral is along the circle mod z equal to 2. Here we are integrating along mod z equal to 2. So therefore this point where this function is not analytic is inside this circle. So therefore we are using Cosi integral formula for integral along mod z equal to 2. But if we consider this mod z equal to 1 by 2, then this 1 is outside this simple closed contour. So this function becomes analytic at all points inside and on this circle mod z equal to 1 by 2. Therefore integral along mod z equal to 1 by 2 is 0. Now we try to do part 2. So in part 2 we have sin z divided by z minus pi by 4 to the power 3, and contour is mod z equal to 1. So we are familiar that value of pi by 4 is always less than 1. So this function sin z divided by this z minus pi by 4 to the power 3, this is not analytic at z equal to pi by 4 only, and z equal to pi by 4 will be inside this circle. So here also we have to apply Cosi integral formula. So for that we consider, if we compare this sin z divided by z minus pi by 4 to the power 3 with this integral f of z divided by z minus z0 to the power n plus 1 dz, then we obtain that we have to consider f of z equal to sin z, n plus 1 is 3, so we will consider n equal to 2, and this function f of z is analytic everywhere, so it will be analytic inside the given circle, and the value of this integral is by Cosi integral formula. This value is 2 pi I over n factorial, nth derivative at point z0. So here we have 2 pi I divided by 2 factorial and second derivative at point pi by 4. So we have to write down all these things systematically, but this is the way how we can think that this is the problem of Cosi integral formula. So problems of Cosi integral formula will look like this: f of z divided by z minus z0 raised to some integer power. So if your function in the integral is looking like this, then you can try Cosi integral formula by considering, here we will consider f of z equal to sin z. So first we consider f of z equal to sin z. Let f of z equal to sin z, and given contour is, I think it is mod z equal to 1 unit circle. So let me check again. Function is sin z divided by cube of z minus 4, and c is the circle, mod z equal to 1. So it is clear that sin z is analytic everywhere inside and on this contour mod z equal to 1. So clearly f of z is analytic at all points inside and on this circle. So if it is clear to us, then also we have to write down all these details in the examination to obtain full mark. So it is analytic at all points inside and on C, that means unit circle, and the point pi by 4 lies inside C, because pi by 4 is less than 1, so pi by 4 lies inside C. So therefore by Cosi integral formula, integral of f of z divided by z minus pi by 4 to the power 3 along unit circle mod z equal to 1 will be equal to 2 pi I divided by 2 factorial second derivative of function f of z at point pi by 4. So 2 factorial is 2, so it will cancel out, and here we require second derivative of f of z at point pi by 4. So it is given, we have taken f of z equal to sin z, so therefore first derivative of sin z is cos z, and therefore second derivative of sin z, which is first derivative of cos z, is minus sin z. So here we find out value of this second derivative at z equal to pi by 4. So here we put z equal to pi by 4 and we have to write here minus sine pi by 4. So this is minus pi I times sine pi by 4, and sine pi by 4 is 1 divided by root 2. So finally our answer is minus pi I divided by square root of 2. So therefore integral of function sin z minus pi by 4 to the power 3 over c, which is mod z equal to 1, this is simple closed contour, is minus pi I divided by square root of 2. So it is by Cosi integral formula. So in this way we can apply Cosi-Ursa theorem or Cosi integral formula to the given complex integral if this condition is satisfied, that function is analytic at all points inside and on a simple closed contour. So I hope you like this lecture. Thank you.